So this film isn't directly about old cars or Enigma machines or anything like that, but it's kind of related to both. This is actually something I've wanted for a while. This is a laser cutter, laser engraver. It's just a cheap one. It's just one of those self-assemble kit toy type ones. They're fairly limited. It's not like as useful as a proper CO2 type laser cutter, but for the price and for what I want to do with it, they're actually really good. They're really good value. Basically, it's a clone of, I think they're called Alex Maker lasers. Very, very common. If you search around on any of the Chinese websites, Banggood or AliExpress, you'll find them. There's tons of YouTube videos around on people who have built these and played with them and modified them. Basically what it is it's a frame, aluminium extruded frame that you assemble, a few stepper motors, a driver, and a laser module. And what this lets you do is laser engrave or laser cut materials. It's very limited, like I say, but I bought it for a very specific purpose for which it'll work fairly well. Now, this isn't the first laser cutter I made. I've actually got a little tiny one here. When I first started getting into 3D printing, I wanted to learn a little bit about how machines worked and how the controllers worked, and the GRBL language and things like that. And when I was working at Weta at the time, they were throwing out a whole bunch of old computers and computer hardware. So I went and snaffled a whole bunch of the CD-ROM drives, and I used those with an Arduino and some little motor controllers inside that box there to build this little tiny laser cutter. And it was more just an exercise to see how the machine worked and get into CNC stuff before I built my 3D printer. And this works reasonably well. It's very limited, obviously. You can only cut or engrave something that's about 30 millimeters by 30 millimeters. But the principles of how this works is exactly the same as how this bigger one works and how any decent sized laser cutter works. It turns out this little one that I made is actually a bit better than this one because it's got a few features that this bigger one doesn't have, like homing switches. You can see there's a micro switch there, which lets this one actually home and have a known zero position. Whereas this kit set one, it's very basic, very simple. There are no limit switches, there are no home switches. Where you turn it on is basically where a zero point is. But if you work within those limitations, it's fine. I am actually considering replacing this controller with the one that's in here because they work the same. So I can use all the electronics and the switches and things in here and put them onto this machine and upgrade it. I have already made some upgrades to this machine. So when you buy them, you get a kit of parts. You get all the framing and the stepper motors and the controllers and the wires and the laser. And what they supply you with is these laser cut acrylic end plates. So these are the plates that go on here, and the motors bolt to them and everything bolts to them. I guess this is a cheap way of doing it because obviously they've got a decent sized laser cutter and they can laser cut all these parts. That's how these would have been made. But what I find is with acrylic, it cracks. So as soon as you try to screw anything into it or bolt things onto it, quite often it'll crack like that. You can see this one's cracked quite a lot. The same with this. This was the top piece here. This is all cracked as well. So the first thing I did is I replaced all of these with some, this is 4 millimeter aluminium plate. And I just designed up new end plates using Fusion 360 and then printed out a paper template and then manually machined these on my mill. And these are a lot more rigid, a lot stronger, everything bolts them a lot better. I replaced the middle ones here as well and made a better mount for the laser module. Another small improvement I made is this laser is a blue violet laser. I think it's a 3.5 watt or 5 watt. I can't remember exactly. And one thing I found really useful on the little laser is to use a red laser pointer. Just a cheap laser diode. I think I got 5 of these for $5 sort of thing. And at the moment it's just running off a little button cell. And I just have that on all the time. So this is set up to point to where the laser beam is going to be. In the software that I'm using, you can turn the laser on at low power and see where the beam is. But for some reason you can't do that, or I haven't figured out how you can do that and get the laser to trace out the path that it's going to cut at the same time, which is a bit pointless. So what I'm actually going to use this for, and the reason I got it, and the reason I got such a large one, is to make gaskets. So this is where the old cars come into it. Often there's a need for all sorts of paper gaskets and things. And although you can buy these, I figured it's easy enough to make your own. And I can draw up the patterns I need for the gaskets, and I'm able to just cut them out with the laser. So the first example I'm doing, this is for the first real gasket I'm going to make for it, is I've been restoring a little 3 horsepower Briggs and Stratton engine. And this is the gasket that goes between the carburetor and the engine block. And this is obviously well past its best. I could buy a new one. I could make one by hand pretty easily, but as a practice run, I'm going to use the laser and see if I can cut it out on that. I draw up the images on Fusion 360. I just draw a sketch and then save it as a DXF. And the software I'm using to drive this at the moment is Lightburn. This is paid software. I'm actually in the middle of the 30-day trial, but I think I'll probably pay for this because it's actually really good software. There is free software you can use. Forgotten the name of it. There's some open source software, but I found that really clunky and really hard to use, like a lot of open source software, to be honest. But this software works well. It just worked. So you can sort of see down here, I've got my little image imported, and use the software to control the laser. So, for example, that's tracing out where the path that the laser is going to follow. Because, as I mentioned, this has no home switches, you have to be very careful where it's going to cut. So it's good to do a practice cut. And that's one of the reasons I've got this wooden board here is instead of shifting the laser around, I can just shift the board around. Now what I've got is some gasket jointing paper. Obviously this isn't as thick as the gasket that was on the engine, but this is where the laser will help because I can cut out multiple of these and then stack them. And because I'm cutting it out on the laser, I know each one I cut out is going to be exactly the same as the previous one. So I've got this sort of lined up. You can't actually see the red dot very well, or I can't see it on my phone screen, but there is a dot there which shows me where it's going to cut. I do that little practice and then we go ahead and cut it. Laser cutting is always interesting, trying to find the right settings for how to cut a particular material because there are multiple factors you can change. So one is the power that the laser is putting out. I just have it on 100% power at the moment. I believe if you reduce the power, you can get a narrower beam, which may be important for if you're trying to cut out very fine things. But for what I'm doing, I just have it on 100% power. And then you can vary the speed that the laser moves and also how many passes you do. So you kind of have to find a compromise between the right speed and the right number of passes to cut through the material that you're trying to go through. So I've done a few test cuts on this. I think this will probably take 2 or 3 passes. The other thing to realize with these little cheap lasers is there's no safety considerations at all. It does come with these sort of cheap laser goggles. I'm not really sure how good these are, but it's better than nothing. So as long as you're careful, they're reasonably safe. I mean, you don't go pointing the laser at people or animals or things that it might reflect off. How I've got it set up here is pretty safe. There's not really anything it can reflect off, although maybe it could reflect off the steel block I've got there to help hold the gasket paper down. One thing I may do is, like I've done here, used a little steel sheet. I may put a steel sheet over the top of this board, because then I can stick down these paper materials with magnets. But masking tape works just as well. When I was working up at the workshop, we used the laser cutters all the time for all sorts of things. So cutting out vinyl for props. There were some controllers we did for a film where I cut the housings, the control box for the electronics was all cut from acrylic sheet and bolted together. They would sometimes cut painting masks out of masking tape, so they would draw out the pattern and then use the laser to trim out the masking tape and then use that for masking things. So they're really, really handy machines to have. Let's put my little goggles on, and if I can change hands, we'll do the first cut on this and we'll see how it goes. Oops, and there's something wrong with it. Let's see. Here we go. That's cutting. Now, one of the things I want to do on this machine is, one, put it into some sort of enclosure. That'll make it safer, and also that'll allow me to do a bit of fume removal. So this stuff you can see is smoking quite a lot, and I suspect that's because it's gasket paper and it's probably got some sort of oil or something in it. It's oil jointing compound. But you can see there the laser's doing its thing. That was one pass and it obviously hasn't gone through, so we can just do it again. Because this is the first time I've tried it with this particular material, I don't know how many passes it's going to take, so I'm just doing one each time and then redoing it. You can set up the software so it'll do multiple passes automatically. I suspect this is going to take 3 or 4. Of course, after this, my whole house is going to smell of smoke. What I'm looking at doing is actually building a big box for this thing. And I'm considering having it mounted in the roof of my garage and have the box on sort of pulleys so that you can lower the laser down. Obviously, you need to keep this clean, so being in a garage isn't the cleanest place. But I figure if this is in a box on a board that then raises up into a box with seals around the bottom edge, I can keep it up out of the way and clean. And the other thing is also in the garage, I can open the door and the garage door and the windows to control the fumes that come off these things. So just do another pass. One thing to note with this kit, these cheap laser kits, is as well as no idea of safety, no limit switches, that kind of thing, there is zero idea of cable management, which is why the cables at the moment are just all over the place. So that's something you have to be careful of. Obviously, you want to make sure that whatever you're cutting, your cables aren't going to get in the way. But I think when I build a proper housing for this, I'm going to get much longer cables, and I'll figure out a way to route them so that they keep well out of the way of the laser. So it's a bit hard to see, but you can see that's starting to lift now, so that's almost cut through. We do another pass. Can't quite tell if that's gone all the way yet. Not quite, so it may need another pass. Well, this is obviously going to take a few more passes or else a tweak of the speed so that it cuts more slowly. But you can see it's getting there. I'll pause this now. I'll go ahead and finish cutting this and we can see what it looks like. I actually slowed down the laser in the end. I am now cutting at 300 millimeters per minute. I was going 450 millimeters per minute earlier. And that's cut through reasonably well. So, you know, that's a perfectly usable gasket. What I'll do now is I'll cut out a few more because I want to stack them. And this is where instead of moving the laser, I can just move the board that I'm cutting on and it'll cut in the same place. And of course we can do the test the framing there, which that's not quite in the right place. And again, this is where my little red laser pointer helps, because I can see exactly where that's going to cut. So I'll go ahead and cut out a few more of these and then we can see how they fit on the engine. So this is the little 3 horsepower Briggs and Stratton engine I've been restoring. I have no need for this engine. It was on an old reel mower that somebody gave me, and I just like pulling them apart, cleaning them up and putting them back together. Engines are just fun. So this one it must be reasonably old. I think the make of this one is 80202. When you look up the parts for them, you find a lot of the parts just aren't available anymore. So I think this is quite an old engine now. This is the carburetor that came with it on top of the fuel tank there, and this is where I need the gasket. So the gaskets go here. So this is my little stack that I've cut. In the end, I worked out for this jointing paper, which is 0.8 millimeter thick, I needed 2 passes at 300 millimeters per minute. And I've cut a stack of them here, and they'll just fit on there. I'm not sure you should really be stacking gaskets like this, but again, I'll put jointing compound between them all, stack them up, just to make them the same thickness as the original one. And like I say, it's just a little engine I've pulled apart and rebuilt for fun. So it may not be 100% technically correct, but it'll work fine. One of the things I am interested to find out with the laser, so obviously it cuts through the paper, no problem. One of the reasons I got such a big laser is because of parts like this. So this is like the front engine cover for the Riley engine. This is in 2 halves. So obviously you'd have a paper gasket that goes between those. And like I say, I can buy those. I'm not sure if I can get them locally through the Riley Club or if they'll come from the UK, but I'm sure they're available. One of the experiments I want to do is take a housing like this is reasonably big, and put this on top of my flatbed scanner, see if I can scan around it to get the outline, and then import that into the drawing program. So I don't have to manually try to draw that gasket shape, although that's not too difficult to do. It's just a bit of measuring and plotting, and then usually I print them out on a piece of just normal printer paper first and just check the sizes. And once you get the hang of doing that, that's not too hard. But these would pretty much be the biggest sort of gaskets I'd need to make. The other big gasket I would need is around the diff and the diff housing cover. So that laser is more than big enough to be able to do these. Just while I've got these out, these I actually had vapor blasted, and as you can see, they've come up perfectly clean. The Riley 9 engine is quite interesting in that this cover bolts to the front of the block, and that's actually the front main bearing. The main crank bearing is there in the cover. The other thing we noticed once this was all clean is this is actually cracked in here, this little mounting lug. I'll be able to weld that up, no problem. But that crack, you couldn't see it before because this was just so dirty and so covered in grime. It wasn't noticeable that was cracked there. So the vapor blasting definitely gets things very clean. I'm not sure I actually like the finish, to be honest, because it's a bit too... It looks like it's painted. It's almost like it's artificial. Probably once it's on the engine, I'm not going to make too much effort to keep it clean. It's going to get oily and dirty, and as long as it's tidy, I don't really mind. I prefer it. An engine should look like an engine, and if the little Austin 7 engine is anything to go by, it'll get dirty pretty quickly. So this one's already covered in oil and water, and I had a petrol leak the other day, so there's been petrol all over the exhaust manifold, which is why this is all now discoloured. But that's okay, because now it looks like a vintage engine. So going back to this other engine, the little Briggs and Stratton, this should work fine, these little paper gaskets. The other thing I want to look at doing is laser cutting silicone. So this is actually a test base gasket I made for the Austin 7 engine. So on the Austin 7, the block and the crankcase are separate, and this actually goes between the two, and it's a notorious place for oil leaks. And what we've found is you can use this silicone baking sheet, and it makes a very good oil-tight gasket. So I want to see if I can laser cut this type of sheet, this baking sheet as well. And it should be possible. I think this stuff laser cuts reasonably well, but I do need to look it up, because there are definitely some materials that you don't want to cut on the laser. So a really good example of that is PVC. So you should never cut PVC on a laser, because the process of cutting it releases, I think it's chlorine gas. But a lot of materials will give off toxic fumes when you cut them, or else they'll give off fumes that will damage your laser optics. I'll have to look it up, but I'm pretty sure this sort of silicone is reasonably safe. So I'll see if if I'm able to try that. But now I've got my little gaskets, I'm going to go ahead and finish assembling this little engine and see if it still runs. So that was the little 3 horsepower Briggs running. I think I've got a fuel leak somewhere, I'm not quite sure where, possibly the gasket in here, but it seems to work pretty well. You may have noticed there was no muffler on there. So this is the muffler that was on it, and it's just completely rusted through. So I think, given it runs quite well, it's worth spending the $20 or whatever it is for a new muffler, and I'll put that on there, and then I don't know what I'll do with it. Build a little car. Don't really need to build any more cars. I've got a couple here that I need to be working on instead of working on silly things like this. Don't know. They're just fun little things to play around with every now and again.